My name's Dr. Ben Newman, and I'm a coronavirus researcher. And nobody asked this, but the paper's out there and it's getting a little bit of press, so I thought we should talk about it. So there's this idea, and it's actually a couple weeks old now, but the idea is that what if the SARS-CoV-2 Omicron variant came from a mouse? Which, on the one hand, nobody was there, nobody was measuring. Anything is technically possible, but we can look at whether it's likely and we can look at the implications, I think. And that's usually a useful way of sorting out fact from not quite fact. Yeah. So let's go. All right. Let's see. Oh, so here's the paper over here. So evidence for a mouse origin, and it's still just a preprint as far as I'm aware. It may show up in a journal near you sometime soon. I have no idea. I'm not affiliated. I don't know any of the authors, anything like that. And so jump down here, past those two, and here's the rationale figure, which is figure 3. And so they took, and this is the part where you gotta look, but they took a bunch of viruses and they looked at what changes you get in these viruses with a thing called principal component analysis. It's a powerful statistical way to sort out trends that you might not have noticed otherwise and kind of rank them in order of most powerful to least powerful, something like that. And they've done that. They pulled out a couple of principal components. And so they're looking at the ways things differ to try and get a big picture view of whether or not there are specific changes that you always see in a mouse virus. Because the idea behind this would be that, well, a mouse has certain proteins. And the mouse isn't going to change its proteins. And so if a virus wants to infect a mouse, it has to change itself and learn how to infect the mouse proteins, right? How to bind them. Which, on the surface, I think kind of makes sense. Then you go into the methods, and the methods are usually where the problem is, and I think they are here as well. So what they did first of all was they selected, here we go, 17 mouse hepatitis viruses, so a particular mouse virus, 13 canine coronaviruses, 54 feline coronaviruses, 23 bovine coronaviruses, and 110 porcine delta coronaviruses. Yeah, neat. Why that many? Why have different numbers in different groups? All those things are a little bit like, I don't know, if you're being really careful, you might not want to do some of those things. So let's look at the ones they picked. And the idea was that they wanted to see if a specific host does something. And so here's a relatively recent phylogenetic tree, just like a family tree of coronaviruses. There have been several added since, and this is not anywhere near all of them. These are a few representative branches done in a relatively competent way. Not the best, but real reasonable, I think. Yeah. And so they're taking, let's see, mouse hepatitis virus, which is over here, beta coronavirus A. There we go. They're taking a whole bunch of those, and they're taking a whole bunch of cat and dog coronaviruses. And so here is the cat coronavirus, and the dog would be canine coronavirus. And do we see that on here? I think, no, it looks like they did not include that on here, but it would also be over here, I believe. They're real close to each other. And then they took porcine delta coronavirus. So you got to go up here to the delta, and so there you go, HKU15 out on this branch. And they left out all the other branches on the tree. Now, if you're just new to coronaviruses, you'd say, seems reasonable, which, yeah, right? Somebody puts out a thing in a preprint with a lot of work in it, and that's the easiest assumption, is to assume they must know somewhat what they're doing if they're going to put this thing out in the world with all this work, right? Yeah. In this case, though, yeah. So that one does infect pigs. But so does this one, TGEV. And so does HEV, which is going to be a beta coronavirus. There it is, HEV over there. And we now know that SARS-CoV-2 also infects... actually, no, does it infect pigs? I'm not sure if it infects pigs. but it infects dogs and cats a little bit at least. And so already we're doing a thing called cherry picking, where we select the data before doing the analysis, and based on the data selection, it kind of controls what the analysis is going to show. And I don't think they're doing this with any kind of ill intent or anything, but I think that the results they get are very much a product of the method that they chose, and I see some problems with both. Yeah. And so then they do some computational stuff, and then they do the actual real test, which is they take the receptor binding domains, that little part that sticks up like a thumb on top of the coronavirus, and actually binds to your cells, just like the little thumb you use to press the doorbell to get into a house. Same deal, except the coronavirus does it. And they find that that domain from Omicron binds very well to the mouse ACE2 receptor. Another thing we should point out is that the coronaviruses they picked, I believe, all go into cells via different receptors. So it's not that you can adjust to a mouse versus a human. They're also adjusting to totally different proteins which look different in mouse versus human. I mean, they don't always have the same parts that are changed. Yeah, that's total nonsense. And then they look at a variety of single changes, and they're just looking at these little receptor binding domains. Now, one problem potentially is that what you're doing here is you're chopping off a little part of a protein and expecting it to act like the whole protein does. Sometimes that works when that protein is kind of independent, when it folds up all by itself and it doesn't need the other protein. But you don't know that. You can't assume that necessarily right from the get-go, and you'd have to test that and demonstrate it. What they did was they picked some of the big variants, which have just a couple changes in there, and they made a couple other individual changes in there, and they showed that some of these changes do, in fact, cause the virus to be able to get into mouse cells better. And so you can say, oh, okay, maybe. But weirdly, they show that alpha, which has been reported by several other groups now to get into mouse cells very easily, and actually you can infect mice with it much better than with like the old wild type strain. They showed that doesn't get into mouse cells at all, which is, I don't know, that's a little dimly glowing red beacon in the background, just sort of flashing on and off in a vaguely worrying kind of way. The same thing for beta and gamma, both of which in other people's hands you can definitely use to infect a bona fide mouse. So I don't know what we're I don't know what we're measuring here. We're measuring something, but there may be problems with the test, and I don't see the tests where they would demonstrate that each of these proteins still binds in the same way as the original virus would bind to the original receptor. Basically to show that the thing that they made is going to work. Take it another way, my arm can do various things like this. If you chop my arm off and set it on a table, it does none of those things, but it still looks kind of like an arm. And it is still the same arm, isn't it? Yeah. So yeah, I think they may have a dead arm on at least some of these. So anyway, based on that, they conclude that, these are mutations that are advantageous for growing in a mouse. Don't seem to have appeared before. They draw this little gray oval so that in mouse, which are these black points that should be in the mouse oval if there even is a mouse oval, they draw it so that it definitely now includes the little red dot down there. Whereas this other virus that infects people, MERS coronavirus, they give it its own circle over there. It's unrelated. So I don't know what to make of that. Fine. But there's also another way we can test this. So let's look. This is a different. This is actually not a preprint. This is a print. It's a published article, early access, and seems to be a decent paper from the parts that I've read so far. I don't see anything that stands out as bad. It looks, fairly competent. Yeah. Anyway, they're doing a similar test. But I believe they are using full-on spikes. So not just little detached arms on a table, but the whole entire enchilada. And what they find is that, yeah, the black line, which for some reason they don't list on their graphs, but it is the gamma variant, and the alpha variant are very good at going into human cells. And Omicron is very good at going into mouse cells. And if you look at human binding affinity, you can see there they did all the tests. They showed that these things they're making still get into human cells at about the same rate that everybody else says they do, and that clinical investigation says they do. So alpha was very good at entering. It's a super enterer. Delta, in comparison, not that super. It gets its powers from elsewhere, from within. Yeah. Yeah, remember there are a couple other mutations in Delta that just make it produce more virus particles, even though the spike is not necessarily better and is actually demonstrably worse at most everything. And you see Omicron is middle of the pack in terms of entry. It's Delta-ish, Beta-ish. None of them are great, but yeah, they're no alphas, that's for sure. And then looking down here at the mouse ACE2 entry. So if the other paper was right, then we would expect for the mouse to be really high, and we would expect all the other variants to be really bad at binding to the mouse ACE2, because that's kind of what they showed in that other paper, but they were working with little detached bits, not with whole spikes even. And I mean, ideally you'd work with a whole virus rather than just even a whole spike, but yeah, baby steps. And they actually are working with some version of that here. I think it's probably a thing called a pseudovirus, but it's closer. It's a lot closer to reality. Anyway, yeah, Omicron is there. It's pretty good. Gamma's there, maybe slightly better or about the same. Alpha's there, pretty good, about the same as Omicron. And Beta is, better than the original, but not quite Omicron level. Although they're only testing this twice by the look of it, unless those are maximum and minimum values. Yeah. And so, if Omicron was selected in a mouse because of its unique mouse binding ability, then that would mean that gamma, beta, alpha, and possibly delta were also selected in a mouse. And to that I would ask, where are all these mice? And it's sort of an Occam's razor kind of moment where you'd say, so these changes that make the virus better at binding human cells had to go through a mouse where they don't bind as well in order to get back to a human where they bind really well. That's the idea? And I don't know. I don't know that I buy that particularly. That seems like convoluted. It seems like adding an extra step that has no reason to be there and doesn't need to be there, and the story works better without the extra step. So anyway, based on this, Omicron looks like it's just something that is differently but still well adapted to entering humans. It's not better at entering human cells than some of the previous variants, roughly on a par with Delta. This one says slightly better. There are other tests that say slightly worse, so average it out. They're about equivalent. But it seems to get its superpowers. The one thing that's really different about Omicron is that the spike doesn't fall apart, as in that other paper that we discussed maybe 3 or 4 videos ago. And other than that, we don't have any other good explanation for why or how Omicron would be different. It has a lot of little changes, but every virus has a whole lot of little changes, and we only ever understand a couple of them, and we do tend to focus on those maybe a little more than we should. But yeah, that doesn't mean that the thing we focus on is necessarily the most important thing or the right thing. So there you go. So yeah, sum it up. Did Omicron come from a mouse? Anything's possible, but no, I don't see any evidence that it did. And in fact, I see some flaws with the paper that showed evidence that they might have. And their data does not seem to be reproduced in this and a couple other studies that I'm not showing, but that show the same thing. So there you go. Hope that was useful in case you run into this out in the real world at some point. Yeah, Mice are fine. Yeah, you don't have to worry about mice and Omicron in particular. Yeah, and not going to give it to you anyway. And they're most likely not a breeding ground for new coronaviruses. They have their own coronaviruses, and that's good for them. Yeah. Thanks a lot. This has been Ask Dr. Ben.